We are live. Hi everyone, welcome back to Code Era. Today in this video, we'll be discussing the LeetCode daily challenge for 16th of Feb. The name of the problem is swap nodes in pairs. Previously, this problem has been asked in a lot of organizations, like it has been asked in, you can say, Facebook. It has also been asked in Uber. It has been asked in Google, Amazon. So these companies have asked this question. So just give me a quick plus one in the chat if my voice is clearly audible to everyone and the screen is visible so that I can start as soon as possible. Right. Also, let me know that if the audio and video are working perfectly fine or not, so that we can start with this particular problem as early as possible. Right. So I guess the notification is there, so people will join in a couple of minutes. So I'll just wait for 1 or 2 minutes for everyone else to join, and then we'll start with this problem. Also, you can let me know if you have solved this particular problem, then what was your approach, whether you did it in a recursive manner or you did it in an iterative manner. So I'll be telling you the iterative approach for this particular problem, because the iterative approach is very much intuitive and easy to understand as well, right? So all of you can just give me a quick plus one in the chat if my voice is clearly audible to everyone and the screen is visible, so that I can start. So let's start. So the problem name is swap nodes in pairs, right? The name of this particular problem is swap nodes in pairs, right? And this particular problem has been asked in Google. It has also been asked in Amazon, and it has been asked in, apart from this, it has also been asked in you can say Microsoft, and apart from this, Uber. So these are the top companies that have asked this question. So all of you can just give me a quick plus one in the chat if my voice is clearly audible to all of you, right? So let's understand what does the problem say. So the problem says that you will be given a particular linked list. Problem says that you will be given a linked list and you have to swap every two adjacent nodes and return its head, right? In this particular problem, what you have to do is you will be given a linked list and you have to swap every two adjacent nodes and return the head of the new linked list of the changed linked list that you have made. And you must solve this problem without modifying the values in the node. Basically, you have to change in terms of pointers. You don't need to change by swapping the values. What I'm saying by this, so let's say if you have these nodes, right? If you have this node, then this node is connected to this node, then like this. If you have a linked list like this, then let's say 1 is present here, 2, then 3, and then 4, like this, right? So let's say these are the values that are present here. Let me write in terms like this. So if 1 is there, then 2 is there, then 3 is there, and then 4 is there. All of you can just give me a quick plus one. Hi Summer, right? So in this particular problem, you have these things, right? You have these things. So what you will be doing is, you might say that okay, you have to swap the nodes alternatively. So you might say that okay, I'll swap this and this. So you'll say that maybe I can just swap the value 2 and the value 1, right? You will say that I can swap the values, like this is having value 1, this is having this is node is having value 1, this node is having a value 2, right? So you might tell me that okay, we might just swap the values, and this would look like 2 and then 1 and then 4 and 3, like this, right? So you'll say that we might not need to change the connections, or the pointers, but you might think that okay, we can just swap and get it. But in this problem, they are saying that you don't have to do it this way. You don't need to swap the values, you actually need to change the pointers, right? So what do I mean by that? I'll just let you know in a minute. So if I have this particular linked list, 1, then 2, then 3, and then 4, and if I had done it like this, that I could have performed the operation swapping 1 comma 2, the values 1 comma 2, and performing the operation swap 3 comma 4. If I had done this part, then what would have it look like? So it would look like 2 1 then 3 4, right? But this is not correct. They are not expecting this from you. What they're expecting is, they're expecting that you change the pointers instead, right? So they don't expect you to swap the values directly. So if you have 1 2 3 and 4, if you have this particular linked list, right? So in this particular linked list, what you can do is, you can simply change the connections. Like if you have this linked list, so the resultant linked list would look like this, right? 2 1 then 4 and 3. So that is how you need to change the connections. So actually this 1 should point to this 4, then this 4 should point to this 3, and this 2 should point to this 1, right? Like this. So this is the way that it should change, and this 3 should finally be pointing to null or the end, right? Is this much part clear to everyone? Please write clear in the chat if this much part is clear to everybody, right? So that we can keep on proceeding further with this particular problem. You can just give me a quick plus one in the chat if this much part is clear to everybody, right? Okay, so this much part is clear, right? So what you have to do is you have to change the connections, right? You have to change the pointers here. यार टाइम चेंज करो, अभी तो ऑफिस खत्म भी नहीं हुआ. Okay, sure, I'll try to change it, right? So in this particular thing, what you have to do is you have to change the pointers, right? You have to change the pointers in this. Like, you cannot do it like that. You cannot just swap. You have to change the pointers like I did. 2 is pointing to 1, then 1 is pointing to 4, 2 is pointing to 1, 1 is pointing to 4, and 3 is pointing to null, right? So 3 is the end of the last node of the linked list, right? So this way you have to do it. So what we can do is we can use the concept of a dummy linked list here. You can say dummy linked list or a temporary linked list. That would be helpful. So how can we implement that particular approach? So if you have 1, 2, 3 and 4, a linked list like this, right? So if you have a linked list like this, so what you can do is you can basically say that, okay, I'll make first of all a dummy linked list. So I'll first of all make a dummy node. I'll make a dummy node. Maybe I can mark it as 0 or something. Let's mark it as 0. Okay, if I make a dummy node and I'm putting a value 0 inside it, so that will not matter, but basically I'm making a dummy node, right? This will be a dummy linked list. So what I'll be doing is this, in this particular linked list, I'll be doing the alternation part that I have to do. Like I have to swap these alternates node and these alternate nodes, right? So this is something that I have to do. How will I do it? Basically what I can do is I have to check, let's say I'm here, right? So you know that what you will be doing is you will be standing at a particular node, right? So you will take 2 nodes at a time. Let's say these are the nodes, so you'll take them. So the linked list would look like 2, 1 and then 4 and 3 like this, right? And let's suppose that you had some linked list like this. If you had a linked list which looked something like this, that is 1, then 2, then 3 and then 4 and then 5, right? So in this particular linked list you can see that this particular node is not having any pair, right? So that's why you will not change it. So this would change like this, right? This and this would remain the same. So it would be like 2, then 1, then 4 and then 3 and then 5 like this, right? Is this much part clear to everyone? You can just let me know in the chat. I'm waiting for your replies, right? So this is how you have to do it. Now once this part is done, so how to implement it, right? So that's why I'm telling you that we have to use the concept of a dummy linked list. What we can do is we can create a dummy linked list, or you can say a temporary linked list, right? I'll try to make a temporary linked list, and that temporary linked list will have initially a node that is 0, right? Let's say it will have a node that will have a value 0, and what I'll do is I'll update the linked list in such a way, I'll update my linked list in such a way that this will be the head of the temp, right? So what I'll do is in the end I'll return temp next, right? So this node I'll return. So that means that this particular linked list I'll be returning, which will contain the linked list in which I'll be swapping the nodes in the alternate manner. What I'll do is, let me take this example that has been given to us. So if I have this example that is 1, then 1 is connected to 2, then 2 is connected to 3, 3 is connected to 4 like this, right? So I'll have first of all a dummy node. So this is the dummy node. So this is the temp linked list that I've made. So basically a temp linked list that I have made. I'll be telling you how I'll be implementing it in terms of code, but just first of all let's look at the concept. So you'll be at this particular node, right? Once you are at this particular node, so you know that, okay, this is your current node, right? This will be your current node. So basically that means that for a current node you need current.next as well, right? So when will you do it? Like if you had a node 5 here, right? If you had a node 5 here, so you know that this particular pair and this particular pair will be current and current next. But if you have a current here, so you know that for this particular current 5 you don't have a current.next node, right? So you will swap those nodes only when you will swap the adjacent nodes only when they exist in pair. So if there is a current standing here, so that means that current.next should also exist. So when will you swap? You will swap if the current dot next is existing, if the current is existing, if the current is not equal to null, and also current dot next is not equal to null. Then in that case you will swap it, right? You will swap a particular adjacent nodes, two particular nodes, only when they are existing in pairs, right? So when the current is existing and current next is existing, both of them are not null, in that case you will swap. Now there is also a concept of a previous, right? You also need a previous for this. So what will be the previous? Currently you know that I have made a dummy linked list or a temporary linked list, you can say. I have made a temporary linked list for myself, right? So I have a temporary linked list. So in this particular linked list, what I am having a 0. So what I will do is, I'll be at this particular current linked list, right? I'll be at the current linked list. I'll be at this particular node, current node, and the current dot next node, right? So I'll be using this concept. So at my current, what is the node at the current is having 1, and current dot next is having 2, right? So how I can try to manipulate it? If my one, let's consider this much part only, right? So if the previous, I'll mark the previous as this node, every time I'll be updating. So every time I will be updating my previous and the current as well, you know that. But initially I'll mark my previous as 0, right? So this is the outside node. So basically this kind of node, I'll say, okay, this is my previous. So this is something that I'll say. So I'll mark my previous to 0, right? So this to this particular linked list, and what I'll do is, I'll have the current, I'll have access to the current dot next, right? So what do I want? I want the linked list to look something like this, right? 2, 1, and then 4 and 3, right? So I want to first of all reverse this much part. Like I want to swap these two nodes, right? I want to change it. Like, so I want 2 first, then 1. So what I'll be doing is, I'll be changing their connections. How can I change the connections? So basically what I'll do is, I'll say that okay, that's pretty much fine. But if I have a 0, right? If I have a 0, so I'll say that okay, since I am having a 0, so that is perfectly fine. But that 0 is what? That 0 is the previous node. Every time I'm updating, you can see that if I'm updating, right? If I'm updating it like this, if I have 2, then 1, then let's say 4 and 3, right? So this node is connected to this particular node, right? So I need to update the connections as well. So that is something that I'll be first of all interested in. So I'll say that okay, this was my previous node. So I'll say that okay, my previous dot next is equal to nothing but my current dot next. What do I mean by that? If my previous is 0, right? I'll say that okay, my previous is 0. I'll assume that there was another node which was 0. Now I will say that my previous is equal to current dot next. So my previous is this node. This node should be connected with this, right? Because this, it should look like this, right? 2 should be here. Then after that, what will I say? I'll say that okay, this much part is correct, right? That is my previous node, that is this node, should be connected to this, right? So that basically, if I am at this node, so whatever value, whatever node is here, it should be connected to this node, right? Current dot next. If the current is standing at 3, so current dot next would be 4, right? So this way I have to connect it. So what I'll be doing is, I'll mark my previous dot next is equal to current dot next. So then 0 and 2 will get connected. After that, what I need to see is, I need to see the relation between current and current dot next as well, right? Current and current dot next, not next. So what I'll be doing is, if the current is current dot next is this node 2, right, and the current dot next is the node 3, so I'll need to update my current dot next, right? I need to update my current dot next. So what I'll do is, I'll basically mark my current dot next is equal to current dot next. So basically I'm doing the updation part in this part. After this, what I'll do is, I have the previous, right? I know that I have the previous. What is the previous node? This is the previous node. What is the previous dot next? Previous dot next is the current node. And what is previous dot next is the current dot next node, right? So what I'll be doing is, I know that this is the node that I have. This node 2, it should point to what? What should my current dot next point to? My current dot next should point to the nothing but the current node, right? So that is what I'll do. I'll say that okay, my current dot next, what is current dot next? Current dot next is also something that is previous dot next. This is previous dot next, and this is previous dot next. So I'll say that okay, my previous dot next that is the pointer to this particular pointer. This I'll say that okay, it is previous dot next. It should point to what? It should point to nothing but current. It should point to current. Then it will point to this one, right? Once I'm done with this part, so I'll always update my current. What will be my current? Current is equal to nothing but current dot next, right? So that means I'll update my current to this particular position, right? My current will move from here to this particular point, like this here. It will move to this particular point, and then what I'll do is, I'll update my previous as well. How will I update my previous here? The simple way to update my previous, why I have done this, right? Why does this help me? My current will not move at this 2. My current will move instead to this point, right? Why? Because I have updated my current dot next to current dot next. Earlier my current dot next was at 2, right? Now I updated my current dot next to this particular point, right? Now the current dot next is pointing to this 3, and what I will be doing is current is equal to current dot next. So basically now at this particular point my current is pointing, right? So my current would come here, and after this part is done, I also need to update my previous. What is the previous node? Now this particular node should become my previous, right? This particular node, this node should become my previous, right? This is the updated linked list, right? So every time I am doing this on an updated linked list, right? Is this much part clear to everybody? Every time I'm doing it, I'm doing on an updated linked list. So that's why this is what, if this was the previous node, then this particular node is previous dot next, right? So what I'll do is I'll say that okay, previous dot next is equal to current, right? So that's why I'll update my previous. So I'll say okay, one more thing that I'll be doing is previous is equal to nothing but previous dot next, right? So in that case what will happen, this will get updated. Once this is done, so again the same process would repeat. Now what is happening is, now what will happen, again this would be the previous node, right? So this would be the previous node, this is nothing but now the previous node, right? And now let's check what will happen in this particular situation. I'll update it again, right? Let me just erase this part so that I can update the linked list. So what will happen is, now this is my current node and this is my current dot next, right? Forget that there was a 5 here. So if this is my current and this is my current dot next, right? What I want is I want that my previous dot next, that is the previous dot next, should point to current dot next, not next. So what I'll do is I'll have the pointer 1 will point to 4. Once 1 is pointing to 4, so what will happen, my current dot next should get updated, right? I'll update it so that I can move forward, right? So that's perfectly fine. But this particular node, this particular previous dot at this particular node 4, I should be connecting 3, right? So how will I connect it? I'll basically connect it by using this particular concept, right? That is current dot next is equal to current dot next, and then previous dot next is equal to current, right? So this way I'll update it, and in the end, once this linked list is generated, so I'll basically return this particular part. That is, this is my temp linked list, right? So this is the head of the temp linked list. So if this is my temp linked list, then what I'll be returning is, I'll be returning temp dot next. So in this way what will happen, this particular linked list will get returned, right? And without doing the swapping of the adjacent indexes, I will be able to access it, right? Is this much part clear to everyone? I hope that it is clear to everybody, right? If you want, so I can write the code for it as well. So let's say that we are writing the code for it. So let me do it. So okay, just give me a second. Okay, so I'll write the code for this thing. Basically what I'll be doing is, I know that these are the nodes that are present for me, right? So let's try and do this. So basically, first of all, I'll have the list node. What is in my list node? I'll create a temporary linked list or a dummy linked list, as I told you, right? List node is equal to new, then list node. And what I'll be doing is, let's say I initialize it to 0 just for having a value, right? And I also need a previous node, right? Previous node is equal to what? The temp, right? That is the new linked list that I have currently made. After this, I'll have a current will point to what? Current will point to the given head of the linked list that's been given to me. Once I'm done with that, so what I'll do is, I'll say okay, temp dot next is equal to nothing but what? Temp dot next is equal to the head of the linked list, right? So that the linked list, the temporary linked list is there that I have generated. After this, once I'm done with this part, so what I'll do is, I'll say okay, my current is not equal to null, and my current dot next is also not equal to null, right? If my current is not equal to null and my current dot next is not equal to null, so that means the adjacent pairs are existing, right? If the adjacent pairs are existing, in that case what I'll do is, I'll say that okay, the previous dot next, what was previous was currently 0, right? So 0 will point to which node? There was 1 and 2, right? The currently the current is what? Current is 1, current is equal to 1, and current dot next is equal to what? Current dot next is equal to nothing but current dot next is equal to 2, right? So what I want is my previous dot next should point to what? My previous dot next should point to current dot next. So that is something that I'll do. My previous dot next should point to the current dot next. Once I'm done with that, so what I'll do is, my current dot next should get updated because I want to go further in the linked list as well. So the current dot next is equal to current dot next like this. Current dot next is equal to current dot next dot next. Once I'm done with this, so I'll update this linked list, that is current dot next. That is now this node 2 will be there, right? Fit 0, 0 will be pointing to 2. Now what is 2? 2 is nothing but previous dot next, right? 2 is nothing but previous dot next, right? In the original linked list, 2 is nothing but previous dot next dot next. If next is standing, if previous is standing at 0, then 2 is what? Previous dot next in the original linked list, right? So that is why what will happen, previous dot next, that is 2 should point to what? Previous dot next should be pointing to what? Current, right? This is what I will do. Previous dot next should point to the current. Once I'm done with that, so what I'll do is I'll mark my current is equal to nothing but current dot next. So I'll update my current because I want to move to 2 indexes ahead. Once I'm done with that, so I'll update my previous is equal to previous dot next. And in the end, once I'm done with this part, so I'll simply return temp dot next, so that I can get this linked list. Let me just copy this particular code. Is this much part clear to everybody? Just let me know in the chat. You can just give me a quick +1 in the chat if this much part is clear to all of you. Just let me erase this part. Let's try and see whether it is getting compiled or not. Okay, temp dot next is not a statement. Why? In the end, I'll return, right? So let me just see whether this is getting accepted or not. Okay, some compilation error again. Okay, you can see that the samples are getting passed. Let's see whether it gets accepted or not. So it is getting accepted, right? So this was the approach that I've told you. Let me just copy the code here and show you what I was saying. Basically what I did in this particular problem was, which question is being discussed? Shivam Kumar, the question is LeetCode daily challenge for today, that is swap nodes in pairs. This is the problem for today, right? So basically this is what I've done. I've made a temporary linked list. First of all, I have added a node that is 0. Then what I've done is I've marked temp.next is equal to head, so that the temporary linked list is containing the complete linked list. Once I have it, so what I'll do is I'll have the previous is equal to temp and current is equal to head, right? Once I am having it, so current is not, if the current is not null and the current next is not null, then what I'll do is previous dot next is equal to current dot next. Basically 0 would be pointing to 2 because 2 will become the first node. After that, what will happen, I'll update my current. Once I have updated my current, so 2 should be pointing to 1, so this is step will be doing that part. Then I need to update my current is equal to current dot next and previous is equal to previous dot next because I need to move 2 indexes ahead, right? In the end, I simply return temp dot next. So this is what I've done in this particular problem. So this was the approach for this particular problem. If you have understood it, so you can let me know in the comments. And thanks a lot for watching, everyone. You can also consider to subscribe the channel, hit the like button as well. Thanks a lot for watching.